Here is a vertical problem that involves having two different accelerations. The rocket starts at zero position and velocity and is blasted upward. During the launching phase, the rocket's engines accelerated upward at a rate of 12 meters per second squared. Once it reaches 1,000 meters, the rocket's motor is cut off. Now the rocket is in free fall and is being pulled downward at a rate of negative 9.8 meters per second squared, causing it to stop. The first variable we will be solving for is the final speed during the launching phase. We call this velocity v1. Let's list our given information. We need to find an equation that allows us to solve for the final velocity without knowing the time. Here is the equation that we will use. Input our data, take the square root, and we have found the velocity of the rocket when it starts to slow down. Next thing we need to do is find the time that it took the rocket to launch. Here's our formula to solve for time. We rearrange the variables to isolate time, input our data, and find our first time. Next, we want to find the maximum height the rocket reaches. We will list our given information. v1 will now be our initial velocity, and y1 will be our initial position. We need to find an equation that allows us to solve for y without knowing the time. Here's the equation we will use. We rearrange the variables to isolate the final position, input our data, and find the maximum height the rocket reaches. Now we need to find the time that the rocket was in free fall. Here's our formula to solve for time. We rearrange the variables to isolate time, input our data, and find our second time. Finally, we want to find the total time the rocket climbed upward. Here is our formula. We will add together the individual times and find our total time.